on another planet.
Hello, everyone, and welcome to another episode of NASA Science Live. My name is Jari Cook, and I'm the News Events and Project Supervisor at NASA's Jet Propulsion Lab, and I'm going to be your host for today's episode. So today we're going to talk about the historic flights of NASA's Ingenuity helicopter and what they could mean for extraterrestrial flight in the future. Over the past month, NASA has been pushing the boundaries of what is possible and turning science into science fact. On April 19th, the Ingenuity Mars Helicopter became the first spacecraft to achieve powered, controlled flight on another world. Since then, it has completed 4 flights that have taken this 4-pound spacecraft higher, farther, and faster than ever before. And now that the helicopter passed its technology tests, it gets to try new things that are all gravy. Ingenuity has just started an operational demonstration where it will try to fly along with its fellow robot, NASA's Perseverance rover, and it will test how well it works as a scout. Ingenuity recently demonstrated that it could fly some fairly long distances, about 1 1/3 football fields out and then back again, taking lots of pictures along the way. The 4th flight was the most ambitious so far. Let's take a look.
All right, I see data products coming in, so I think we're ready to begin processing. All right, telemetry should be in.
I have a plot to show here, showing helicopter flying out and back. That's us going out and back.
So that's a room full of happy engineers at JPL. The Ingenuity team is currently working on planning their 5th flight. So we hope they get to look that same way again soon. But for now, let's talk to the experts. So because this historic flight on Mars has implications for how we will explore other worlds, we are joined today by both a Mars helicopter pilot and a team member from NASA's upcoming Dragonfly mission, which will take flight to a whole other world, Saturn's moon Titan. You can join the conversation too. Submit your questions about Ingenuity and Dragonfly using the hashtag AskNASA, and we'll answer as many as we can throughout the show. So right now, with a nod to Asian American and Pacific Islander Heritage Month in May, I'm joined by Johnny Lamb, a pilot for Ingenuity, and Nishant Mehta, Deputy Lead for the Dragonfly Mobility System. Thank you both so much for joining us.
Thank you for having us.
So Johnny and Nishant, titles at NASA can be a little bit technical. Can you explain what your titles mean? What do you actually do on your missions? So Johnny, we'll start with you.
So my day job is actually a guidance and control engineer, which is also a little bit technical too. So on Ingenuity, I worked on the team that developed the flight control algorithms and the flight control software. And now that Ingenuity is part of a operations phase, I'm one of the pilots, which involves doing a lot of the flight planning that gets loaded onto the helicopter, and then downloading the data off the helicopter and analyzing the post-flight results afterwards.
And what about you, Nishant?
Thank you, Jerry. I work at the Johns Hopkins Applied Physics Lab in Maryland, where I'm in a team of scientists and engineers working on what we call mobility. Mobility is the system that will tell Dragonfly how to fly from place to place on Titan without human intervention. My main job on a day-to-day basis is to help coordinate activities across certain aspects of mobility. For example, one of the things I do is work with a wonderful group of people on the cameras and algorithms that will help Dragonfly tell Dragonfly where it's going while it's flying on Titan. I'll also add that in terms of titles, they can be hard to understand, very cryptic sometimes. So folks working on Dragonfly will often use the term Dragonflyers.
Nice. So we've got a Dragonflyer and a Mars helicopter pilot with us today. All right. So Perseverance carried a lot of technology with it to the Red Planet. One of the technology experiments is the MOXIE instrument, and it just showed us the other week that oxygen can be extracted from the Martian atmosphere. And that'll help with launching rockets off of Mars and eventually making oxygen for astronauts to breathe. The META instrument helps prepare for human exploration by providing information about weather, climate, surface radiation, and dust. So Johnny, what kinds of horizons does the Mars helicopter technology demonstration open up for future NASA missions?
So I think with the success of Ingenuity, we basically kind of unlocked an aerial dimension to exploration. So we've always kind of had the orbiters who can provide observations from up high above, and now we've always had rovers who can provide observations from way close to the ground. And now this kind of provides us another dimension to kind of explore that gap in between, where we can kind of reach some hard to reach areas. We can provide images, reconnaissance, we can scout ahead, we can look for the best path to traverse. And eventually all these things can also help with human exploration on Mars or other planets.
Yeah, and I know that you guys have done a lot of testing on Earth. You know, there's like a space simulation chamber at JPL, but what have you learned from flying this helicopter on Mars that we couldn't gain from flying it in the simulation chamber on Earth?
So that's a good question. So we spent a lot of time in the 25-foot space simulator at JPL. Now it's a pretty big chamber, but we're a pretty small helicopter. But even with all that, we were only able to ever go about a meter up off the ground and about half a meter side to side. And we always had a lot of cables and wires and ground support equipment, all while trying to simulate a Martian environment. Now we're here at Mars. We've been kind of freed of all of this, and we're allowed to just kind of soar the skies. And what we demonstrated is we actually can control flight in the actual Martian environment. And as was shown in like Flight 3, we were able to fly 50 meters downrange, which is the farthest and back, and that's the farthest we've ever gone. And in the process, we're validating all our models, all our testing. We were able to kind of inform and refine our models. And it turned out a lot of it matched really well. And now we're collecting all this valuable engineering data back so that we can kind of help data mine it and improve our knowledge for future missions. Now, as we move on to kind of an operational demonstration phase, we're going to learn how to work with Perseverance. We're going to try to scout and try to figure out how to play together so that we can inform future missions on how they would handle this in the future.
Yeah, so it's going to be a little bit like a buddy movie. All right, so what makes it really hard to fly at Mars is that the atmosphere is really thin, but at Titan, Saturn's largest moon, it's a different world entirely, has a much denser atmosphere than Mars. And Nishan, I know we've talked about how, you know, if you were to kind of get some speed going, you could actually soar for quite a bit of time on Titan on your own. So what can the Dragonfly mission learn from the Ingenuity Mars helicopter?
That's a great question. I'll say that we are always learning from past space missions. Here at APL, every time we build a spacecraft, we apply those lessons to later efforts. In particular, we were very excited to see Ingenuity fly on Mars. While there are a lot of differences between Ingenuity and Dragonfly, there are also a lot of similarities when you're designing and operating a vehicle to, on another planet, especially to fly. One example is that flights for both Ingenuity and Dragonfly are autonomous. Titan is very far from Earth. It takes over an hour to send data to Titan and over an hour to get that data back. Because of that, we can't simply have someone driving or flying from the Earth. We need to Dragonfly to be able to go from place to place on its own, like Ingenuity. And so Ingenuity's, the team's experience flying autonomously on Mars will be very valuable. We'll learn from the challenges they faced and how they solved them. And I will say that another reason I'm really excited about Ingenuity and Dragonfly, of course, is that they provide, these missions provide inspiration. They'll inspire future ideas for planetary exploration and certainly help us push our boundaries even further. And these missions also inspire the next generation of scientists and engineers. And I hope that students, like my own daughters, will be inspired to pursue space exploration. And who knows, maybe themselves work with Dragonfly when it gets to Titan in the 2030s, continue exploration of Mars or other places in our universe.
Yeah, and it's pretty hard to figure out how to fly on another world. So, Nisha, why would we even want an aerial dimension to explore Titan?
Yeah, I think Johnny put it very well earlier. Flying opens up a lot of new possibilities for us, right? We can cover a lot of ground, a larger area than we could otherwise. We can do our science investigation in a lot of different places on Titan, both on the surface and collect data while we're in the air. And in particular for Titan, actually it makes a lot of sense to fly since it's relatively easy. Thanks to, like you mentioned, the really thick atmosphere there and low gravity. In fact, Titan actually has lower gravity than Earth's moon.
Great, yeah. So, lots of different kinds of worlds in our solar system. So I see that there are questions coming in online. If you'd like to submit a question to be answered during the show, use the hashtag AskNASA or comment in the stream wherever you're watching this. So our first question is from Erica Liebel on Twitter asks, what has surprised you the most about Ingenuity's accomplishments so far? Why don't we start with Johnny, and Nishant, you can let me know if you had anything that surprised you.
I would say that the most surprising thing has been how well everything has kind of performed on Mars. We've been looking at these flights, we've been getting back the data, we've dug into it, and they've matched extremely well with our models, with how we tested it, and it's been a very pleasant surprise. I mean, it's wonderful to see.
Nishant, did you have anything that surprised you as you were watching the Ingenuity flights?
One of the things that surprised me, usually in space flight, right, you try to use hardware that has been tested extensively in space, and you don't want to take those sort of risks. But with Ingenuity, learning that they had used common cell phone processors, for example, is really inspiring, and it was really surprising to me and wonderful to see.
Great. Next question comes from Moon to Mars Quest on Twitter. Will flight testing of the quad chopper Dragonfly be similar to Ingenuity performed at JPL's high vacuum chamber, or somewhere like NASA Armstrong or the Applied Physics Lab facility? I guess, where will it be tested, Nishant?
Yeah, that's a great question. So the drone, we have a model drone that we fly to test our algorithms and sensors and so forth. As the video is currently showing, we will fly that at various locations, a lot here at APL. We plan on going out to deserts out in the western U.S. to run some flight tests there. But that's not the end of the story. So the actual Dragonfly lander is quite large. It's about the size of Curiosity, actually, the size of a small car. It makes it very difficult to test the full-scale lander here on Earth. We can't build a chamber quite that big. And so what we'll do is supplement our drone flight tests, the test drones that we're building, with simulations. A lot of simulations to cover all the various possibilities of what we think we might experience when we get to Titan.
Great. And so Cinechem on Twitter asks, and I'll apply this, Johnny, you can talk about Mars, and Nisha, you can talk about Titan. What is the greatest challenge to a successful flight, and how did you overcome it?
That's a good question. So I think always the most challenging parts to the flight are going to be the takeoff and the landing. It's certainly where everything kind of works or doesn't. For the takeoff, we kind of we have a scheme where essentially we apply a large amount of thrust to kind of hop it off the ground. And at that point, we kind of do a controlled flight up to the altitude that we want to. And then on landing, we actually drive it down at a meter per second, coming down, and then we wait until we detect enough velocity error to determine that we've actually reached the ground and end the flight.
And Nishant, what about Titan? What's the greatest challenge there?
There are a significant number of challenges. we haven't gotten there yet, but I can say that a couple of things that we're looking at include the thermal environment. By that I mean the temperature on the surface of Titan. It is very, very cold, about negative 300 degrees Fahrenheit, which is kind of hard to fathom, right? We don't have any equivalent experience here on Earth. And designing a lander that can survive those temperatures and operate on those temperatures is a challenge. And I'll, so, what Johnny said is also true, right? I mean, building something that can take off from one location, fly to another autonomously is difficult and will be one of the many challenges we'll face.
And if I may, I'd like to add a little bit to what Nishant was saying. He's right. Survivability is actually one of the bigger challenges as well. And there's a lot of work to being able to survive a cold night in Mars, and all the work that went involved to having the heater there to keep it at a certain temperature, keep it there alive, having it wake up every day. There's a lot of work that went into that and a lot of testing.
Yeah, I remember Mimi Ong, the project manager, saying she would be so happy when the helicopter survived its first night.
There was a lot of excitement for that.
Great. Okay, so because everyone always wants to know about pictures, Adrian on Facebook asks, can Dragonfly record videos and send it back to Earth as well?
That is an excellent question. We have a set of cameras on board Dragonfly, a science set of cameras called Dragon Cam, and a set of cameras that we'll use just for navigation, something we call our nav cams, which is what we'll use for mobility to fly from one location to another. We'll be taking pictures, certainly. We'll be taking pictures very frequently as we fly. However, I wouldn't necessarily call it a video. We're not going to be able to collect high rate, like 30 frames a second or 60 frames a second kind of videos and get all that data down to Earth. There are a couple of challenges there. One is, just designing a system that can handle that video data rate with everything else that's going on board the lander. So, for example, our navigation cameras, I can speak to those, will collect data as we're flying at about 1 picture every second, which isn't very often. The next challenge is how do you get all that data back from Titan to the Earth? It sounds easy, right? You have a big antenna on Dragonfly and you start sending data, but for those of you that sort of understand what data rates look like, we're talking about 10-ish bits per second from Titan back to Earth, which is not a lot. And so, we will be spending a lot of time optimizing what data we want to bring down, working with the scientists to figure out what's most interesting, and when we finally get to Titan, implement that and get what the best data we can down.
Yeah, and Johnny, there's some cameras on board Ingenuity as well, right?
Yes, we have 2 cameras. One is our navigation camera. That's kind of our black and white camera, pointing mostly down, slightly forward. And that's where that iconic first flight image comes from, where it took a picture of its own shadow. And then we have the color camera. We call it the RTE, or Return to Earth camera. And that's the one that's taking the images also a little bit more forward facing. Now, we don't have video capability there. For the color camera, we take some images. For the navigation camera, we collect more images, so we kind of have limited data recording, if you will. That's as long as we can get all those images down and process them in that way. But we're overall kind of restricted by processing load. Trying to collect that much data is kind of a lot while in the middle of trying to maintain flight at the same time.
Right, and there have been some videos that came back, but they were taken by your buddy, the rover, right? And I know that we have some great orbiters around Mars that have been able to kind of give us those high data rates. We'll have to see what kind of support, I guess, you guys have at Titan. You don't have a relay network yet there.
No, the plan for Dragonfly is direct to Earth communications, what we call DTE. So yeah, Dragonfly has a large antenna, what we call the high gain antenna, or HGA, which will be communicating directly back to Earth. Yeah, we don't have any other support at Titan.
Okay, well, there's another question about Dragonfly, and I don't know, Nishant, if you've, said on all these things, but Robert Hilgrub on YouTube asks, what are the specific dimensions being proposed for the Dragonfly mission?
Yeah, so we're still in the middle of the design phase, so there are things that will change. If we're fairly close to about the size of a small mini type of car, or or even Curiosity. I don't have the exact dimensions off the on the tip of my tongue here, but you can think of it as a small car.
Cool. Okay, yeah, which is much larger than Ingenuity, which I think the fuselage is like the size of a tissue box, right, Johnny?
Yes, that's about the correct comparison.
Yeah. Well, here's a question about the helicopter. Douglas Arajo on Twitter asks, what is the flight ceiling on Mars, and how does that compare to Earth for a helicopter of similar size?
The flight ceiling, I guess I'm not completely understanding that question, perhaps. So,
like, how high could it go? Since I think the atmosphere gets a little bit thinner, right, as you go up?
Well, I mean, I think our limitation right now is kind of our sensor package. We've been comfortable flying with the altimeter at 5 meters altitude. And we're also planning, we are also comfortable probably going as high as 10, maybe 15 meters altitude. But beyond that, we start to get a little cautious, because things might not work well at that altitude. So that's kind of our limit at the moment. But all the flights up to this date have been at the 5 meter altitude.
Yeah, okay. So let's see. Oh, speaking of, you were talking about sensor, but here's a question about energy. So Randonaut on Twitter asks, what kind of energy could be used for the next generation of helicopters for long flights?
Is that directed to me or to?
Yeah, Johnny, I guess if there's like, let's say there's a helicopter that goes on, but yeah, Nishant, why don't you talk about the power source for your rotorcraft too? But Johnny, why don't you go first?
Well, I mean, for the Mars helicopter, we have that solar panel. It's that rectangular strip you see at the top, and it's been performing well for us. It's giving us plenty of charge for overnight, over the course of the day, so that we're ready and able and power healthy each day that we're on Mars.
And Nishant, you're much farther away from the sun, or you will be. So how do you guys get power?
Yeah, we can't use solar panels, unfortunately, when at Titan. But we use a power source very much like Curiosity and Perseverance do. It's what's called an MMRTG. It's a bit of a mouthful, a multi-mission radioisotope a thermoelectric generator. It uses the decay of materials to generate heat, which gets turned into electricity on board. And so what Dragonfly will do is it'll use that, and that provides about 50 to 60 watts of power. We'll charge batteries on board, which will then be used for flight and other activities.
Okay, great. Yeah, and it's a power source that's been used on many missions before, too. Okay, well, that's all the time that we have for today. So thank you for joining us, Johnny and Nishant.
Thank you for having us, and go Ingenuity.
And go Dragonfly.
Okay. If you'd like to stay updated on the Mars helicopter, visit go.nasa.gov/Ingenuity. And to learn more about the Dragonfly mission, visit dragonfly.jhuapl.edu. Be sure to keep up with the Perseverance rover as well on Facebook and Twitter, as the helicopter moves into this new phase, graduating, if you will, into an operational demonstration. Perseverance will also begin to focus on its science campaign, which includes searching for signs of ancient life on Mars. And you can follow along by visiting nasa.gov/perseverance. And since we've been talking about turning science fiction into reality, I should also wish everyone out there a happy Star Wars Day this May 4th. May the 4th be with you. NASA will be celebrating throughout the day on social media, so stay tuned for some fun surprises. Science fiction encourages all of us at NASA to dream big, and we can't do things like fly on Mars or Titan without the expertise and knowledge of those around the agency. During Asian American and Pacific Islander Heritage Month, we'd like to honor some of these employees playing key roles at NASA. Here at JPL, for example, we count Chen Xuesen, a Chinese-American specialist in fluid mechanics, as one of our original founders. We'll close on a video sharing words from some of our Asian American and Pacific Islander employees. Thank you so much for joining us. Until next time.
Hello everybody.
你好
Hi, konnichiwa.
Hello 大家好
Hello, my name is Wen Shanquang.
你好了嗎？我嘅名係朱無基。Hi, I'm Kelly Busquets. I'm an engineer with the Goddard Space Flight Center.
Mabuhay. My name is Tony Arviola, and I work at Langley Research Center.
My name is Karthik Sheth. I'm an astrophysicist working in the Science Mission Directorate.
This is Kenji Miki.
My name is Jenny Staggs.
My name is Steve Shi. I'm the Associate Administrator for Diversity and Equal Opportunity here at NASA.
I'm a research materials engineer.
I'm a program analyst.
I work as a software engineer.
I do research on electric propulsion.
I came here from Japan long time ago, hoping that I could work for NASA. Actually, this is my favorite picture that I kept near my desk for a long time.
I am proud to be an Asian American.
And I'm so proud to be a part of the NASA family.
I'm second generation of Vietnamese and Taiwanese descent.
I grew up in the Philippines.
I'm Indian American.
I'm Filipino. Both my parents are from the Philippines.
I come from India.
I am really honored and blessed to be part of an organization that embraces diverse backgrounds.
But never in my wildest dreams did I expect to be working at NASA.
I am profoundly deaf, which makes me a unique person who is a deaf Asian employed at NASA.
I'm an ambitious woman and I do not let anyone discourage me.
I'm so grateful for the opportunity to work at an agency where our work benefits the entire world.
You notice my speaking. I have some speaking problem on top of a Japanese accent. But in NASA, no one care about it. They just care what I'm doing. So it makes me very happy.
Thank you for joining us in celebrating Asian American Pacific Islander Heritage Month.
Happy AAPI Heritage Month. 대단히 감사합니다.
All right, thank you.
Paalam.
再见
Namaste, vanakkam.
Bye bye. Joikin.
ありがとうございます。さよなら。